This thing is so much easier.
Okay.
Okay. So, good afternoon, ladies and gentlemen. My name is Nils Peter Flint, and I'm sitting here with Michael Carus from Nova Institute, and we are sitting here in the Ministry of Foreign Affairs in Denmark, in Copenhagen, where Michael has been attending a very interesting conference on biofuels and biomaterials and biochemistry and many other things. So Michael, we'll turn the camera around, and here he is, the famous Mr. Carus. And Michael, tell me a little bit about what is Nova doing, and afterwards I'd like to talk a little bit more about what...
Nova is a consultant and research company with a focus on bio-based economy. Bio-based economy means food, feed, biofuels, and especially bio-based chemicals, bio-based plastic, bio-based materials. And we are working in this field on feedstock supply. Is there enough biomass for all the different applications? We're working on techno-economic evaluation of the process, of the new processes, market research for the new products, life cycle assessments and environment footprints, dissemination, and also on the political framework to fulfill the full potential of bio-based economy.
Cool. So, tell me, what we were discussing yesterday was a little bit about this model, which I think we can just show it here actually on the computer. It's called the eternity model, and basically it's a cascading model, and it's a very old model, which I did years ago, and which I'm still very fascinated by, and you know an awful lot about cascading as such. Mm-hmm. So, just try and tell me a little bit about what are your sort of points of views in terms of long-term cascading, which is what this is all about. What I'm trying to project and what we've been talking about is to creatives, scientists and creatives together, project maybe up to 1,000 years ahead in order to try and have a discussion about how we can circle things better than what we do today.
Yeah, I think cascading use is a very old system. Mankind is using it for thousands of years, because if you have not enough material, to have to use material in the most clever way, and to have highest resource efficiency, you have to use material in cascading use. That means, for example, we can use the example trees, wood, timber as an example. You can use first the wood for construction in houses. They can substitute, for instance, steel or something like that. Yeah, like we see here in this nice building. And you can then in the next step, this can last for 50 years, 100 years. And then the next step, you can make, for example, some particle boards out of this timber. In between, perhaps before you use it like this, or parallel, you can also make furniture out of it. Then, we see also nice woody furniture here. And after the lifetime, you can, as I said, you can make particle board out of it. That you can do 1 time, 2 times, 3 times. At the end, you can use particle board as input for pulp and paper industry, so we can make paper out of it. You can use, you can recycle the paper 1, 2, 3 times, and then at the end you can use the cellulose still for some composites, and then at the final end you can also use it for incineration. So you have not only used it 1 time, but 2 times, 3 times, 10 times, and if you just incinerate it, you can only burn it once. Then it's gone. And that today the policy very often is supporting with subsidies to incinerate wood. So you use it in an extremely short cycle or no cycle at all. That is not very clever. And now we need new political frameworks to realize cascading use or your idea of eternity model.
So you were talking yesterday about wood and the fact that these amazing what is actually happening? This I suppose this is oak, and this must be at least 400 or 500 years old oak in this building here. Now, what you just said yesterday was that we are taking oak tree today and we are actually turning it into pellets and burning it immediately, which is complete insane, isn't it?
That is really happening. due to the huge demand for woody pellets due to subsidies. In Germany, for example, 50% of the pellets coming from byproducts, yeah, from the sawmills, that's fine, and 50% coming from new fresh wood. And there could also be some oaks between them. And this, of course, is not a very clever use of wood, of course. It's not very resource efficient.
So what I'm suggesting and what I hope that actually we together can do somehow, and maybe with companies also, is somehow to actually find a smarter way of doing these kind of things. And finding new models where scientists, designers, architects, etc., that are working together and actually helping businesses through various think tanks, etc., actually to come up with new, smarter solutions.
Yeah, that's a very good idea, I think. Yeah.
And that's what we will be doing, Michael.
And a lot to do in this sector. We only talked about wood, but the same is true for starch, for sugar, for hemp fiber, for almost everything. Every biomass we can use very clever in cycles, in cascades, and at the end, the energy sector will get it back, but at the end, not at the beginning.
Maybe here at the end, could you just describe a little bit about what is happening in terms of bioplastics, and because that's one of your sort of your fields and which you know an awful lot about.
Yeah. Some people talk about the third industrial revolution. That means that our economy today is mainly based on crude oil. And this means the third industrial revolution means that the industry will completely switch to biomass, so for the post-petroleum area or period, and this of course also including all chemicals and plastics. And this is an exciting switch in mankind. And in the plastic sector, for example, today we have a production about 700,000 to 800,000 tons of bioplastics already, bio-based plastics already in the world, with a 2-digit growth every year. So it's a very interesting new sector with many big players and also some small players. And from a technical point of view, it's already today possible to substitute 90% of the plastics around you by bio-based plastics from a technical point of view.
From a technical point of view.
It's still too expensive, but we have to prepare it for days where crude oil will be extremely expensive. Today we have prices about $120 a barrel, but if the oil really comes short, we can have very quick $500 or $1,000 a barrel. And then, of course, we would be very happy to have alternatives, bio-based alternatives. And we have to start today to develop it, to have complete new processing lines to be prepared for the high-priced oil period.
And I'm just seeing, just behind you is a painting which could be acrylic paint that's actually been used. So we are basically going to see a complete substitution of basically everything based on petrochemicals into being biochemicals within the coming, what time?
Nobody knows. In the next 5 to 50 years, I would say. It's mainly depending on how much crude oil we really have left, but nobody knows, because what Saudi Arabia really has is a complete secret.
Yeah.
So, but nobody knows when this day will come, but we have to prepare, and we need about 5 to 20 years to develop all the new processes and optimize it.
But there's one thing which I just came to think about, which I also actually wanted to talk to you about, and that is this whole thing about actually storing storing oil into plastics and rather than burning it. We talked about that yesterday as well. Would you mind just sort of repeating what we were talking about yesterday?
Yeah, of course. Also, in plastics, it's the same truth as for the wood. We should also recycle plastic, and in some countries, it's already about 80–90% of the plastic is recycled. So we should also keep the plastics in the cycle as long as possible. And this is already today possible with new technology. And so we have to collect the plastic waste. We have to make difference between different plastic types, and then we can make recycling up to almost the same level as virgin plastics are. And this is true for fossil-based plastic, but also for bio-based plastics. It's the same. And this might be very important in the future. And we see, for example, when now industry is looking for some rare metals, as they open the waste fills in the cities, for example, to get access to all the rare materials, that shows it's much easier, of course, not to put it in the waste landfill, but directly to recycle it. Yeah? And this will be the future, of course. And we should strongly support in our society and political environment this recycling, cascading use. That's the only way to keep on long term the high living standard with limited resources.
And for 10 billion people.
Yeah, exactly.
Michael, thank you so much.
Yeah. Okay, good. Oh, this is only for my wife.
Yeah, I thought so.
Hi Schatzi, mach dich fein fürs Interview.